Hi, my name is Robert Hitlin. Today's three-phase problem-solving lesson is focused on operations and algebraic thinking standard number 1, using addition and subtraction within 20 to solve word problems. The problem I selected for students involved adding with start unknown. My reason for choosing this type of problem is because the language of these problems can be difficult for students to understand. These types of problems can be found in the California Mathematics Framework for first grade. Because my students are first graders, I chose to only focus on 2 math practices. Math Practice 1, which calls for students to persevere and problem solve, and Math Practice 3, which correlates to my language objectives, to have students discuss and answer questions of each other. So in today's math lesson, we're going to do a lot of talking and listening. So we have what they call a language objective. Language is listening and speaking, right? I incorporated an English language objective into my lesson because the majority of the students are English language learners. Do you guys remember when we read Swimmy?
Yes.
Okay, what was Swimmy about? Can you tell your partner what Swimmy was about? A school of fish. You guys remember that word, school? Yes. Okay, I want you to talk to your partner, and I want you to talk about what is a school of fish. All right, let's read it together. In the before phase of the lesson, I make sure students understand what the problem is asking. We clarify any unfamiliar vocabulary and identify what information is given in the problem to help the students solve it. I do this by having the class read the problem aloud and by building in think, pair, share. Some fish were swimming in a school. 5 more fish joined them.
Then there were 12 fish. How many fish were swimming before?
5 more fish joined them. What do they mean by joined? What does that word mean? Yes.
That they came with the other group.
In this question, what exactly are we trying to find out? Gael?
We are trying to find out how many fish were there before.
Okay, so boys and girls, do we agree that the question is asking how many fish were swimming before? Yeah, so let's underline that on our paper. How many fish were swimming before? Boys and girls, what information do we know to help us solve the problem? Yes, Jimena? Circle 5 more fish. What other information do we have to help us solve the problem?
Then there were 12 fish.
Circle 12 fish. We're going to try to solve the problem in more than one way. Everyone, look where my finger is, where it says explain. Explain.
How you know using models, pictures, numbers, or words.
For this lesson, students had a variety of tools to select from to make sense and solve the problem. Would someone like to share with us how we might show our work using models, pictures, numbers, or words?
You can use counters and pictures and linking cubes.
We're going to work on our problem for 5 minutes. I allowed my students 5 minutes of independent productive struggle time to find an entry point into the problem. Okay, so 5 minutes by yourself first. You guys ready to solve?
Yes.
All right, you may begin. So how many fish joined first? 5. At this point in the lesson, I circulate, monitor, and guide student learning through questioning. If we already have 5, how could we get to 12? What could we do? Count up? Okay, let's count up. Did you work by yourself and try to solve the problem? Yes. So if you did that, you can check off. You can put an X or a check that you did that. That means you met the objective. Did you show your work, your problem solving in more than one way?
Yes.
Did you use counters, models, pictures, words?
Yes.
If you did that, you can check that box off too. Okay, so first, you're going to explain to your partner how you found your answer, and your partner is going to listen carefully. Remember we talked about that? You guys remember?
Yes.
And then you can ask your partner questions, how they solve their problem. Students have an opportunity now to share their thinking with their table partners. To facilitate this conversation, I provided students with discussion stems that help them formulate and verbalize their thoughts. Okay, so why did you choose 5 counters?
Because it says 5. I solved the problem by using fishes, using
Joined. Okay, so 5 more fish join them. Did you ask each other questions? Okay, ask Brittany how she solved the problem.
How did you solve the problem? I solved the problem by doing part.
Oh, okay. Can you restate what Brittany said?
She got the part, and she got the other part, and she found the missing part was 7.
She found that the missing part was 7. What does that 7 mean, like in the problem?
7 fish.
7 fish, right? 7 fish. As I circulated around the room, I looked for multiple solution paths by students to share in the after phase to advance the mathematical thinking of the entire class. So now we're going to have a few people share different strategies that they use to solve the problem. In the after phase, students share their strategies with their classmates. Gael shared a part-whole diagram. Okay, let's look at what Gael did first. Think about what he did before we talk about it. Everyone's looking at it? Okay, now that you had a chance to look at what he did and think about it, turn to your partner and think, what did he do? Students were familiar with this visual representation, and it gave everyone access into the problem.
Well, I wanted to do a part whole, so I wanted to know that 5 plus 7 equals 12.
What did you start with when you did the part whole?
The whole is right here.
And what does that mean, the whole in this problem?
I found the 12 fish that were there in the storm.
I allow students to discuss Gael's representation of the problem. Turn to your partner and think, what did he do? Now that Gael had a chance to share his solution, does anyone have any questions for him? Gael, why don't you call on someone? I see a lot of hands.
Why did you use a part whole? I wanted to use the part whole because I wanted to tell that the 12 is the whole and the 7 is the missing part and the 5 are the ones that come later.
Jimena's solution path involved using counters to solve the problem. This strategy allowed students to see how tools can be used to access and solve the problem. Counters are a concrete way for students who are struggling to visualize the problem. What do you think Jimena did to solve the problem? Let's think about it first. Everyone's looking at it. Okay, when you're ready, talk to your partner about how do you think Jimena solved the problem?